We shall be looking at the NEET Test 3 electrostat.
Quite frequently asked varieties are there, so I think it will be really quick. Let's see. The question number 121, we had discussed this before. See, they're comparing work done to carry, we say it was in O. O is at center, not at anywhere at the other point. Um, the work done to carry from OA to OB, OC, OD. O would be this point, not the center. Sorry, I would rather, my bad. I would erase this. Yeah, OA, OB, OC, OD. They are comparing the magnitude of the work. Well, we say work done is change in potential energy, and potential energy only depends upon the end and initial position, the final and the initial position. Have a look at this. The initial potential energy, QQ, since this is a radius, and this distance and this distance are the same because the q is the both the points are on the circle itself, so both the points are equidistant from the center. In the center there is plus q, so potential energy of the charge q didn't really change when it came from 0 to a, so I can say work done is 0 in 0 to a. So I can say for all points from O to B, O to C, O to D, potential energy change is zero because initial point and final point are equidistant from the center. So all the work done is zero, equal to each other. So I'll go with P. Question number 122, a spherical conductor Q of radius A. It is being placed in one more conductor. This radius is A. The charge that flows from, a charge plus Q is given to this. Suddenly it is connected to the outer conductor. Once I connect it to the outer conductor, I can consider that both the inside conductor plus this plus the outer one, the entire is one huge conductor. And we know that charge cannot stay inside a conductor. Net charge inside is zero. Therefore, all the charge that was given to the concentric or the inner sphere should actually move through the wire and transfer to the outer sphere. So what was the charge that flowed from the inner sphere to outer sphere? It is Q itself. So 122 goes with A. Now 123. 123 is really interesting. They are telling where is the electric field finite. In other words, I have to interpret this. Then where is electric field not equal to zero? We know charge when the field inside a conductor is zero. If I have given charge on A is a conductor. So inside A, obviously field will be zero. Field inside a conductor is zero. But they're asking where is it and not zero. Um, what if we consider between A to B? Between A to B, the field is not zero. If you have had a careful look at our NCRT electrostatic shielding concept, if I give any, if there are charges like this over here, on the inner surface, there will be some negative charges induced. So there will be field lines which emerge from the positive and go and terminate at the negative like this. So there are field lines between A to B. The field in the region AB is not zero. So where can I say electric field is not zero? In the between A and B. That is the most reasonable choice, right? So that would be 123 on the surface of B. Well, on the surface of B, as you can see, it is Earth. So charges would really drain out. Okay. So let's not go to the B part or the outside B part. It is only in the between the region between A and B. The field lines emerge from the inner one and the it is terminating on the outer one. So 123 goes with in between A and B. What about 124? An electron enters a uniform electric field with initial velocity along the direction of the electric line. If this is electric field lines, an electron is entering whose velocity is along the field line. Well, we know electric electron experiences the force in the opposite direction of the field line, so its force experience will be in the opposite direction. Velocity is in the forward direction, force in the opposite direction. Therefore, the electric or the electron will slow down. Electron will slow down. So what would happen to the velocity of the electron? Velocity of the electron would decrease. Why? Because it is slowing down like a car under brakes. You should see, should feel that the force experienced by an electron is always in the opposite direction of the field line. Question number 125. In question number 125, they're asking what is the x component of the force on minus q1 proportional to? So many variables over here. So I would rather go for substitution, and I will put theta to be, say, a very easy number. Let's say put theta to be 0. If theta is 0, then minus q1 is over here, minus q3 is over here, and q2 is over here. Right? X component of the force now on q1 is only due to the q2 part. So if I put theta as 0 in the option, I should get some option which is dependent only on q1 and q2 and b square, q1, q2 and b square, right? So I put theta equal to 0 here. I get Q3 also because cos 0 is 1. Therefore, this is not the correct choice. If I put theta as 0, I get Q2 by B square. Okay, acceptable, but not at certain. If I put theta as 0 here, again I get 1. Not correct. If I put theta as 0, yeah, acceptable. Q2 by B square. It is minus Q3 by A square sin theta. Here it is plus Q3 by A square sin theta. What is the other thing, that other substitution that will help? What if I put theta as 180 degrees, or sorry, theta to be 90 degrees? If I put theta as 90, then this charge would be over here, right? So now theta is 90. This minus q1 will feel the force of repulsion due to this minus q3 in this direction, and it will experience attraction towards q2 in this direction. Both forces will add up. So if I put theta as a 90 degree, I should see both q2 and q3 adding up because they are giving a force in the same direction. That happens only in B, not in D, because in D there is a minus sign. Put theta as 90, you'll see sine 90 is 1, there's a negative sign, therefore it is 125 goes with B. I have given you an approach which is solely based on substitution. Well, what about question number 126? There is a neutral conducting sphere. A positive point charge is placed outside the sphere. What is a net charge on the sphere? So imagine a metallic sphere conducting. So I have put one positive charge over here. What happens is it will attract most of the negative. The other positives are out there. So it is not uniformly distributed. The reason being, the negatives will appear crowded at this surface and the positives over there. So charge distribution is not really, you know, uniform. So negative and positive appears. There is, I mean, in the options there is negative and dash. So insert a positive thing. But what is a net charge on the sphere? The net charge on the sphere is the charge is just separated. Electrons are separate from the nuclei, but the net charge is always 0. So net charge goes to 0. Induction basics, whenever charge is induced, net charge is 0. Question number 127. Potential and field strength at a certain distance of points are 600 and 200. What is the distance of the point from the charge? Well, both the potentials and the field is positive, so charge should be positive. So what I would say is E equal to kq by r square, that is 200, and V, which is equal to kq by r, just is 600. I just need to find the value of r. So I divide the two sides. kq's gets cancelled. 200 goes to 600 as 1 by 3. And see, there's a 3 involved, right? Which of the options has 3 involved in it? That would be option D, hence D is the right answer. Question number 128. In 128, torque acting on electric dipole in the field is maximum. Torque is PE sine theta. So torque is maximum when sine theta goes to 1 or theta is 90-degree formula based. It should be, you should be answering this subconsciously because this has been, one of the very famous questions in dipoles. Question number 129. An electric dipole of length 1 centimeter is placed with an axis making 30 degree to the electric field of strength is experiences a torque of 10 root 2. What is potential energy of the dipole? Well, potential energy formula of the dipole is minus Pe cos theta, where theta is the angle between the dipole axis and electric field. So theta angle is given as 30 degree. And torque is given as Pe sin theta. So making use of the two common formulas of dipole, potential energy and torque. Torque is Pe sin theta. Now they're asking what is potential energy? Well, I can simply I can divide the two equations. Once I divide the two equations, right, uh, it will be simply U by tau, right? It is equal to PE and PE gets cancelled minus tan theta. The ratio of potential energy and torque is always equal to negative of tan theta. Theta is given. Torque is also given, which is 10 root 2. You don't need the electric field data and the 1 centimeter data at all. It is simply to waste your time. You simply divide the equations. U by tau is tan theta. So U should be equal to tau times or 1 by root 3 times 10. Okay, 10 into root 2 by 3. That would be more precise. So you multiply 10 root 2 into 1 by root 3, approximate the number, whatever you get. That is the option. That is question number 129. U is minus PE cos theta, torque is PE sin theta. Question number 130. The electric field intensity E due to an electric dipole moment of P at a point on the equatorial line is very famous. At a point on equatorial line, it is always opposite to the direction of the dipole moment, right? It is opposite to direction of dipole moment. Only one of the options says opposite to direction of the dipole moment, and it is parallel to the axis of the dipole. Dipole moment is always, let's say it is from negative to positive. At this point, it is opposite to direction of dipole moment, but along the axis of the dipole. So it is option A would be most appropriate. Question number 131. Three concentric metallic spherical shells. Let me draw the concentric metallic spherical shells. The key concepts involved here are induction and induction only. If I give a charge of Q1 to the inner one, I put a charge of Q1 over here, the inner surface will induce a minus Q1 charge and outer surface will have induced a Q1 charge. See, that is the whole idea. And the outer sphere already has a charge of Q2 and the outermost one has a charge of Q3. You see, so if I put a Q1 charge in on inner one, on the inside surface it's minus Q1 net charge. If I consider this as a conductor, net charge has to be 0, so Q1 minus Q1 goes down to 0. On the outer one, Q1 plus Q2 appears, but if I consider this as the conductor, inside net charge should be 0, so here there should be an induced charge of minus Q1 plus Q2. Well, if minus Q1 plus Q2 comes here, on the outermost one, it should be Q1 plus Q2. So the charge on the innermost sphere, let me label this A, B, and C. Charge on A is Q1. Charge on B, okay, on B, it is Q1 plus Q2. Charge on C is Q1 plus Q2 plus Q3. Why? You may have given Q1, Q2, Q3 on the surface, but you need to include the induced charges as well. Once you know the charges, we can simply you make use of this. Surface charge densities on the outer surfaces are equal, which means sigma A equal to sigma B equal to sigma C, which would be in QA by R1 square equal to QB by R2 square equal to QC by R3 square. I know QA, QB, QC, which is these. R1 is R. This is just R. This is a 2R, and R3 is 3R. So I know the radii as well. If I put the numbers, I'll get a neat equation. From that equation, I can calculate the ratios of Q1 is to Q2 is to Q3. That is question number 131. Question number 132. Electric dipole is placed at an angle of 30 degree to a non-uniform field. Repeated a lot of times. Non-uniform field. Dipole will experience both force and torque. It should be option C. Question number 133. Which point charge placed at the center of a cubicle? It's in the form of a cube. Edge is 55 centimeter. What is a net electric flux through the surface? There is a cube. In the center of the cube, there's a charge. Flux is always given by Q enclosed by epsilon naught Gauss law. So I simply put 1.8 by epsilon naught. I'll get the answer. But remember, all options have 10 power 5, 10 power 5, 10 power 5, 10 power 5. I will not calculate the powers at all. I'll simply calculate the numerical part. 1.8 mu c, which is 1.8 charge by, it would be the epsilon naught. Epsilon naught value is 8.8 something. C, if I put 8.8 as around 9, right? I would say it is two, it goes as 2 times. So the best guess in the exam hall circumstances would be option C. With question number 134, the inward and outward fluxes. Any flux which is pointing out is positive. Any flux which is incoming is negative. So it would be 4, it is plus 4 and minus 8. That would be net flux. So it should be minus 4,000 units would be the net flux, but I want the charge. So flux is charge by epsilon naught, or this into epsilon naught. I can eliminate A, B. Between C and D, only one option has something into the epsilon naught. So that would be option D. I will go with D. You don't even need to do the calculation. Simply see which of the options have epsilon naught multiplied, because we know phi is Q by epsilon naught. Put epsilon naught over there. So Q has to have epsilon naught multiplied with it. So 134 goes with D. What about question number 135? Well, uh, when calculating the flux, okay, the flux through this dotted surface depends only on the charge enclosed. Okay, it depends only on plus q1 and minus q1. It doesn't depend on q2. But so for this question, answer is D. But what about field? If I have to calculate field at the outer surface, then it will be due to plus q1, minus q1, and q2. Field due to will be all charges, whereas flux will be due to only enclosed charges. That is the funda. So this is the NEET paper discussion for NEET test 3. All solutions pertaining to electrostatics. I hope this was of real use. Do physics, have fun with physics, and NCRT for you guys is very mandatory. Many questions here are directly based on NCRT examples. Thank you very much. Take care. Bye-bye.